Sometimes I catch myself wondering why folks prefer using the as operator over casting. Then I realize it makes them feel safer. But is it wise to pick safety over security? Safety over security. What's up, YouTube? Welcome to this next episode on the Let's Talk series. This one is about the as operator versus the cast expression. And I want to kind of set the record straight with regards to some guidelines as it pertains to this as versus alls. The typical guideline is always use as. I don't know if you guys have heard this. I've been in a few companies now where the coding standards were very specifically stating this aspect, always use as. And I believe Bill Wagner's book, I don't remember the name of it, but I think it's Bill Wagner, but he mentions the same guideline, and maybe it's all coming kind of from there. If I remember Bill Wagner's books, this is from many, many years ago, so I don't actually remember the exact things, but there's a series of some of these books, or maybe just new versions, new publications. He mentioned the reason was, it doesn't throw an exception. As doesn't throw an exception, while cast does, and some performance benefit and all that. So I'm not sure where or why exactly this guidance comes. I think personally that this is a misguided guidance. It's not practical. It's not for the real world. It's more like theoretical, because it doesn't throw an exception, it must be safer. And safety is not the same as security. Safety is about safeguarding yourself from unintended, let's say, attacks, if you will. Attacks, just kind of loosely, attacks in that sense, not necessarily personal, but some sort of intrusion, some sort of a danger. So it's an unintentional thing. Whereas security is about an intentional thing that it's going to happen and you need to take measures. So these are security measures, not safety measures. Safety is more like some of it is also emotional. There's an emotional component to safety, I think. I'm not an expert in all this, but I'm sort of just thinking about certain times one would use safety versus security. So you wear a safety helmet that's as a protection in case something happens. Right? It's not expected to happen, but in case it does. Whereas security is more of the intentional things. You know somebody's going to break into your house. So you know that somebody's going to do this. And so you have a security protocol. And we have this in software as well, right? Many software for automobiles and spaceships, these software go through much higher level of security analysis to ensure safety with regards to the code and the application or the system is trying to operate on. Right? So safety and security, where safety is more to do with will the system behave correctly at the right time, versus security is more to ensure that there are no issues caused at, let's say, at the memory allocation level, or even from hacking perspective, to ensure the system is always performing the way it's supposed to, because those are intentional attacks, if you will, versus safety is more like a precautionary afterthought, not necessarily afterthought, but reactionary measure, whereas security is more a proactive measure. All right, enough about safety and security. Okay, so the as operator and the cast expression have been around for many, many years. I've actually used the as and is operators and cast expressions in other languages as well. For example, Delphi has both as and is. I don't know if C++ has that. I don't think so. Anyway, Delphi has it. And the behavior is the same, and the guidance in Delphi would have been the same. So there's no real difference between C# guidance, if you will, the way I would, propose the guidance versus what I would say in Delphi. It's the same thing. Both the as expression will not take into account user-defined conversions, while the cast expression will. So that's a bit of a nuance. In some ways, I personally think that the fact that the as operator does not support user-defined conversions is a benefit. You don't know what a user-defined conversion is? Okay, good. Then you haven't missed anything. If you haven't used user-defined functions, please don't. It's not something that I would recommend at all. It's like any other operator overloading, even though the features there has been there in C++ and C#, I would never use that feature unless there's a equality thing going on with regards to value semantics for reference types, which, by the way, we'll get out of the box in C# 9 with the record type. So rather than you doing it, let the the compiler do that, compiler lowering step, kind of handle that aspect. So that's more automated and it's kind of seamless, but at the same time, there are no chances of mistakes or abuse with regards to the operator overloading, or in this case, user-defined functions. But nonetheless, today's discussion makes a few assumptions, which is you understand how the as operator works, how the is operator works, and how the cast expression works. So this is not a video where I'm going to teach you how they work. And you have a fairly good understanding of how they work. For example, the as operator will likely return a null in case the type cannot be converted to the type you asked it to, whereas the cast will throw an exception, right? So that's an assumption I'm making. You understand that. The other thing I'm going to assume is, given the code samples that I'm going to show you, these are code samples that are kind of deeper in the guts of the system. They're not at the entry points. And so if you program like I do, where we lock the front door and we lock the back door so you're safe in the house. If you don't know what that means, you can take a look at this video here where I explain, amongst many, many other aspects, locking the front door and locking the back door so you're safe in the house. It's assumed that this code is deeper in the system, and so it's the parameters being sent to certain methods here are not null because they won't be. Right? It's just never happen. And so we don't have to ensure or check for nullability. As a result, these are non-null reference types, if you will, right? Okay, so let's look at the code. There's three code samples here, fairly small, I'm hoping. They're pulled out of context, so I'm hoping they don't lose the value, if you will, because they're pulled out from actual code. So I'm hoping you're not thinking, oh, well, I don't write code like that. This is real code. I see this a lot, not just in my code, but just generally I see this kind of code a lot. And so I'm using it as a way to show you some common code that I see and how to fix that, or what's wrong with them and then how to fix it. So this is more like a code review thing. So when I show you some code, look at it from the perspective of a code reviewer. What do you tell me to fix? All right. Okay. So, and the third one is a valid use case for when to use the as or the is, in this case, specifically the is operator versus the cast expression. All right. Okay. Let's get started. Okay. So we have two separate methods here. They both got the same name. One has a suffix of 1 and the other has a suffix of 2. Very simple. My employee type is the base class, and both the software engineer and the accountant descend from the employee base type, right? The software engineer type has a role property that only the software engineer has and the accountant does not, right? So in other words, they are in a hierarchy. Employee is an ancestor to software engineer, and software engineer is the only one that has a role property, while the accountant type does not. So what would you say is wrong with this code, and what would you say is wrong with this code? I'll let you pause here for a bit, take your time, and then once you've understood the code, made notes, whatever, or you want to write a comment saying this is what I think it is, fantastic, write that there, and then continue watching the video to hear what I have to say. And if you have something different to say, or if you have a bit of heartburn, write me a comment. Let me know what your issue is, or what you think, or why you're thinking a certain way. So maybe you're going to teach me something, or maybe I can explain. Maybe I'm not explaining things correctly. All right? Okay. So the first question I'm going to ask you here is, or I'm going to make a statement and ask you a question. Both these methods do the same thing, is it not? They're doing the same thing, but they're saying different things. You get it? The question you have to ask yourself is, what is this code saying? What is it telling me? That's like the difference between, let's say, body language. And I'm not an expert in body language, but I'll give you an example. You could go research the web for sort of better ideas about what I'm saying. But essentially, it's like this. Let's say, you're on my team and you say, hey, Shiv, you come up to me, kind of by surprise. And you say, Shiv, this other design you gave me is, it's not working the way it's supposed to work. And I've got a better design. then you propose, I'd like to show you. And I would say, yeah, sure. Let's see. And when I do that, I'm really being defensive. I'm not open to your suggestion. It's not always the case when somebody folds their hands, I don't think. But if you come to my house and summer or winter, you're going to be folding your hands all the time. It's cold. I keep my house cold. Even in summer, I like cold. I don't like hot. And so you'll be doing this all the time in my house. So that doesn't mean that you're uncomfortable or you're being protective. What I'm getting at is the code could be doing one thing and it could be saying something else. And programming with intent, which is pretty much most of my channel, I talk about these ideas, programming with intent ideas. You want to program to show me your intent. In other words, you are communicating as clearly as possible your intention by writing code. No comments, just code. Your code should speak to me and explain or convey your intent so that when I look at this code later on, while I'm doing a code review or 10 years from now, I'm not wondering what you were thinking because you have communicated your intention really clearly. So I'm not second guessing. And if I know that's how you programmed, then I'm in a much better place in the future. Either it's my future self or me as the person maintaining the code you wrote, whatever that future is. If I could just be assured that you programmed with intent, then I never second guessed the code you wrote. And I am better informed about how you were thinking, what your original intentions really were. All right. So these two pieces of code, they do the same thing, but what are they saying? I'll give you a moment to pause, think about what I'm asking and see if you can answer that question. And then I'll tell you the answer. All right. So let's go look at what I think these two pieces of code are saying. Okay. Let's look at this method first here. Now, the first question, the astute programmers of you would say, but shouldn't this employee be a software engineer? Both of them just need a software engineer. Exactly. So the first thing I would catch you if I were doing the code review would be, why is that just not software engineer? And if you don't have a good answer, I'm going to say, well, then change it, right? Because you don't want to assume from at the out of the external part, in this case, the method signature, the public surface, if you will. You're saying I'm accepting of any software engineer, but internally you're not. Sorry, any employee. But internally you're only accepting a software engineer. Well, then don't kid anyone. Right? Don't lie to me about saying that you want to do that generically. So don't try and build generalized software unnecessarily. If you need only software engineers to be here, then fix the signature and the ambiguity is immediately eliminated. All right? Get that? Okay. However, in this case, that's not true in the sense that there are many times where you might need to have that employee as the method signature, while internally you're only dealing with software engineer. It's not uncommon because of probably sometimes polymorphism, because the signature has to be such that it's working with all the entire ancestry. And sometimes, like say in events in GUI applications, sender and object. So it's always going to be object, right? And sender. It's such a high level abstraction that anything can come through, and it has to be because any event can be sending you any object. It could be a button or a text box or a form or whatever, right? So in this case, let's assume that the employee is the right signature of the method. We're looking at the implementation, all right? But if you didn't catch that employee aspect, then you need to sort of rethink your code review strategy. You should be looking for those kinds of things. All right. So I'm going to tell you what I think this code is saying versus what this code is saying. This code is saying, well, I can get an employee, so I'm not quite sure that every parameter that comes in here is a software engineer. So I'm going to use the as operator, and I'm going to assign the as, cast the converted version of that to this variable software engineer. And yes, I understand that it'll be null, but I'm going to, of course, call into the role method, the role property of the software engineer, because that'll work. And yeah, there's an issue here with regards to the null check, not check. Now, this is very common. I see this all the time. And really, this is a symptom for the another problem, but I'm going to get to that later. I understand there should have been a null check, but you will see, you can look at your code currently, your code base, you'll find there are many times you will use the as operator, but not use a null check afterwards. And that's indicative of a different scenario, which I'm going to get to. All right, so this is saying you're not sure right? However, by not doing a null check here, you're actually confusing me because saying, okay, on the one hand, you're not sure that this is going to, the employee is always going to be a software engineer, yet you never check for a null. So you're going to get a null reference exception here. I'm not sure, was that intentional, or are you really telling me that this employee is always going to be a software engineer? You see the confusion? You write code like this, your intention is not clear. Now I'm confused. Like if I look at this code as somebody who's maintaining the system or doing a code review, I'm not quite sure what you mean or what are you saying when you write code like that. Let's look at this code. Actually, I won't scroll up and down. It just becomes difficult to. Okay. This code is saying, well, this employee just has to be a software engineer. Just using the cast expression, or what I call a hard cast, as in there's no, it bloody well will work on, else it's going to throw an exception. And it's going to be assigned here, and immediately I just go for all. In other words, it will never come to this line and throw a null reference exception. However, it would throw a typecast exception on this line. Right? Safety versus security. Which do you prefer? The first one where you could potentially get a null reference exception, or the second one where you could get a typecast exception? Okay, I'll tell you. The typecast is way better. The null reference is going to be useless to me. I don't know what that would mean. The typecast is going to very clearly tell me that's a problem. Now, the question really is, when that occurs, even if it's a null reference exception, when that occurs, what's the solution? What's the fix? Now, most of us will jump to fixing the problem where you find the symptom, which is, on that line where it throws the exception. Oh, it says null reference. Okay, I just need to check to see if it's not null. You are now creating a false sense of security. And that's the problem. You think you're being cautious, you're securing yourself from a potential attack, but effectively you've hidden the problem. The problem is still there. You just evaded the problem. So you said, it's not my issue. I'm not going to deal with it. I'll let somebody else deal with it. Never trying to find a solution by treating the symptom. Try and find the solution by finding the root cause and then finding a proper solution that prevents the problem from occurring at the root itself, rather than fixing or treating the symptom. Make sense? The second method, the casting option is saying, very clearly, the code is saying, I'm not expecting this to be nothing but a software engineer. So if it's not a software engineer and you get a typecast exception, caller, you fix your problem. I'm not going to fix it. I'm doing my code just fine. I'm expecting only a software engineer at this point in time in my code, right? And that's a valid assumption to make, and it's a valid intention to show. Again, the symptom is not where you fix the problem. You'll see the typecast exception happening in the second method, but the solution may be to fix it in somewhere up the call chain. How did a non-software engineer instance come down here? Because this code is very specifically made for a software engineer. I hope that makes sense, right? So sometimes actually all the time. I've learned this the hard way many years ago when I started programming. I was shit scared of exceptions. I mean, exceptions were like my nightmare, right? Aren't they? It's like, oh my gosh, another exception. Or in those days, GUI applications, they would just crash. And so everyone was petrified of exceptions, including myself. So all the code I wrote was in this preventative, defensive mechanism of trying to defend against an exception, like being defensive. I don't want to see an exception. Today I'm much smarter. In those days I wasn't. So what I'm getting at is being scared of exceptions is the wrong thing. You need to embrace exceptions. Exceptions are there to help you. Okay? They're giving you an early warning signal about something going wrong. Right? The problem is when people start to get scared of exceptions, they put try catches and they try to do whatever they can to evade or avoid exceptions. And I believe the guidance on as, always use as when you want to do a cast or conversion instead of the cast expression, I think comes from that style of thinking. And because I don't think in that way, I think the better option is to let the exception occur because the statement is clear. Let's try and fix this. Let's say you say, okay, well, why don't you just put a null, check over here. We say, okay, let's do that. So if software engineer is not equal to null, right? then let's do that. And then what? What's the else about? Where's the else? What do you do in the else? And you could say, yeah, well, there's nothing to do. And that's quite possible in some cases. I'm not saying that's not a scenario, but that's not generally the expected scenario. Okay, the times I've seen this problem is when the else should never have occurred to start with. You understand? So that's when you want to say, let's use the cast expression rather than the as operator. Right? So this is the correct solution, and this is not. Because you're hiding the problem. Yes, it won't throw an exception. You'll only come in here if it's not null. But when it's null, what happens? It's like a silently just pass through. It's like the guy that doesn't have a badge to enter your office just walks through the back door and is in. That's not what the intention was of security. The security was to make sure that everyone comes through the gate and only those who have the badge can come through the door. You don't want a back door, right? All right. So let's look at the second code base, second code solution. Okay, I've got two of these. I'm going to show you both. Let me show you how this code would be used, right? So let me fix that. The main method here, I'm going to just comment out this code and write out some new code here. All right. So the idea is we have the genre enum. Let me show you that. And let me close this for a bit. Okay. So every enum element has an attribute associated to it. And the attribute can be sort of the description, if you will. There's many times where the enums can only be one word, like a C# type name, while the description could probably be multiple words with spaces in it. And so you want to have this enum that tells you what the human readable form is, for example, like psi-5 versus psi-5, which is how you can specify the enum element here, or the field, if you will. These are called enum fields. So the program CS is essentially getting the collection of enum fields, and that's the field infos. The field infos is the collection, the runtime metadata of every one of these genre fields, right? The one that I showed you earlier, these ones. Oh, that's over here. So it's a collection of each of these, but inclusive of the metadata, so the attributes that come along for the right, right? That's what the field infos is. And then we're calling a method that says initialize. It should have been initialize genre to description mappings. And that's what I'm showing you here. Let me also open up the parser 2 and split that horizontally. Okay. And let me see if I can just squeeze this up a little bit. Line it so you can see the full method body for both of these methods. All right, one more. Okay, that's it. This is the full. You can see the close curly here. All right, so pause the video, see if you can determine which one is the better one or the right one, on the way to do it, and then I'll continue on. All right. Okay. So this is was the original code, and we are working with that enum description attribute here. And this is the standard method in .NET's reflection namespace. We can ask it for the type of the type you want, and then it's going to get you the custom attributes of that type. And then over here is using an as to convert that result. It comes back as an object array. The idea is to cast that to an enum description attribute array, right? So what this is then is of type enum description attribute. Let me see if I can zoom that in. Can you see that? Okay. Okay. So there are a few problems here. If you haven't noticed them or haven't picked them out, pause and then I'll continue on. I'm going to start telling you what the issues are and why and what my reasoning is, and then the solution, which is the one on the top, and why that's the better solution. All right. So the first problem is that if you ask this method to get this type, then it can't be any other type. Using an as doesn't make sense. You're again confusing me. Are you saying that even though you're asking it to get you this type of an attribute. It could be something else. So you're hoping for the best. So you're sort of playing it safe, or can you not just cast it? Right. So that's the cast over here. So we're casting it over here versus using the as. All right. The second thing is a guidance from .NET. The guidance goes like this. If a method returns a collection of some sort, enumerable, array, what have you. If a method returns a collection, that method should never return a null. All right. And the BCL, the base class library, the .NET C# Teams library, if you will, uses that guidance. So their methods will never return a null if they return a collection. There'll be empty collections, but not a null collection. All right. So right away, you can see that this condition will never be met, which means this code can never be tested. Code like this, this branch, if you will, of the conditional will never be tested. And so you've got some piece of code here that you never test and yet you're going to put in there. So that doesn't make sense, right? So you can take that out. Now, if the collection, what's returned here is an empty collection, then the for each over here, down here, will just be skipped anyways. And so now you have this whole condition, this whole thing doesn't need to be there in the first place, right? And so you have the solution here. Now there is a nuance here where it's checking for the length is equal to 0, so continue. But here we're not doing a length check. So of course, if the collection is empty, it implies that in this case, the attribute, there is no attribute associated to that field in the enum, right? Now, in this particular case, that's the requirement. The requirement is if you have an enum, then every element or field in that enum needs to have the attribute declared on it, irrespective of whether the description is the same as the enum or not. So as a result, having a length or not having a length check is a valid scenario in this case. But if you had a different way of doing things, then you could say, well, then in that case, we want to check the length 0. So, I mean, you would still have to, the idea is in this specific case, it sort of makes it easier to not have the length check and have the rule that says that every field, enum field should have an attribute associated to that, because the logic gets a little more complicated if you understand what the actual code is doing. But for this purpose, or for the purposes of this discussion, just assume that the length check is not always required. It's not wrong. But again, only use it if it makes sense, right? Because again, if you don't use the length check here and it blows out with the length of 0, right? What are you saying? Well, again, the problem is not here. The problem is that you need to go back to the enum and decorate that enum with the attribute, right? Don't fix it here by trying to be safe again. So, be aware of that. All right, hopefully these two examples, which are very, very, very common, have made sense to you. And now we're going to go on to the third example, final example, where I'm going to show you or make a case for when you should use the is or the as operators. When is it right to do that, right? Okay, this code is available on my GitHub repo. I'll put a link to the entire solution in the description below, but this specific file is the exception to HTTP translator class. You can look for that. The idea is that this class's purpose or responsibility is to take a C#.NET exception and translate that to HTTP, which would mean, of course, if it's an exception, then the status code might have to be changed to a 400 or some series of 400 or some series of 500, right? And you might want to have to take the message of the exception and put it in the HTTP context, or the content, if you will, of the body in the HTTP protocol. And in my case, I also set up a header that gives me the type of exception that occurred on the service side, right? Because sometimes the client side, which is also an internal service, might have to rehydrate an exception of the same type and throw it. So in this particular case, it's doing three things. It's setting the status code appropriately, which is the main logic here that I want to show you, like what should the status code be. But it's also setting the header with and the reason phrase, right? So let's take a look at that. So setting the header. So this is the entry point, the public method, that's private. So you can't get to this, directly. You have to call the public static method here. Providing it with an exception. In this case, again, the exception base class is a requirement because any and all exceptions that occur in your system will come through here. So there's no way to fine tune that further or confine it further to a specialized kind of exception, right? So the header, we're going to just say exception type header, and it's going to be the type name of the whatever the exception is. So that's irrespective of what the exception type is. Now this reason phrase property, which is available in our exceptions. By our, I mean the system is the movie service system. And so there is a base exception called movie service base exception. So all our exceptions, not non.NET exceptions, all our exceptions descend from that base. So the .NET exception is up here, the root exception. The systems exception descends from that directly. And then all of the systems exceptions descend from here, not from there, not from the .NET exception. They all descend from here. In this case, it's called the movie service base exception, right? And from that movie service base exception, there are two kind of branch, technical base and business base. So essentially, we have technical exceptions and business exceptions that both descend from our movie service base exception, right? And then the business exceptions will be like a horizontal or a broader sort of descendant tree, not deep. And the same with technical, they kind of be from that point forward, it's sort of flat, right? It's not going deeper. Hopefully that makes sense, because you're going to need to understand that to look at the rest of the code. So what we're saying here is that the movie service base, if this exception is, so we don't know. So we can't be sure. And it's only if it is, do we want to do something? Right? You could use as in some situations. In this case, I don't need an as. I just need an is. So in this case, this is using the new C# pattern matching feature in C# 7, I think it was. So it's kind of like a as, actually. I'll explain to you if you don't know the syntax. You look at that, it's saying if exception is this is the type declaration, that's the variable declaration. If the condition is true, this variable will hold a reference to a movie source base. In other words, it has cast this exception to that all in one breath. So it's kind of like a as operator with a null check built in, right? So even though you're seeing it as a is, it's actually it's an as from non-expression matching, if you will, syntax. Make sense? All right. And so we're saying if the exception is one of our exceptions, then all our exceptions have a reason phrase exception or reason property. So set the reason phrase HTTP header to that. But it's only available on our exceptions. Therefore, we can only do this when it's one of our exceptions, right? So we need to ensure or check that we do this only if it's one of our exceptions, right? Now, when it comes to setting the status code, we have another method here. And this, again, is for all exceptions, right? Now, one could say you could sort of optimize it by saying, okay, you know the status code, but this is the base class. So the status code for business exceptions could be of like a 400 series. Technical exceptions could be like a 500 series. So you don't quite know yet. And in this case, we only know that it's the base class. We don't yet know whether it's a technical or a business exception, one of our technical or business exceptions. So we couldn't optimize too much here. So it's basically being done over here once and for all exceptions. We send that exception to this method here. So again, this signature says I need an exception type. And it says, well, if it's a movie service not found base exception, so that's a business exception not found, it returns a 404. But if it's just a movie service business base exception, then it's a 400. In other words, they're saying for all business base exceptions and descendants, our response status code should be a 400 unless it's a not found business exception, it's a 404. And for all other exceptions, the status code should be a 500, which is all of our technical exceptions, and every .NET exception is considered technical or 500, right? Hopefully that makes sense. But this is probably the only time, and in fact, for the most part, I don't know for how many years now, this is probably the only time I actually use the is or as is combination of operators. Most times I use a cast, right? So hopefully this is making a lot of sense. Hopefully these examples have made sense as well, even though I've kind of pulled them out from the main systems, the main code. You might think that it's a bit not quite engrossing, the example, but I'm hoping I did a good job. All right. So this brings me to the end of this video. I hope you've learned a few things. I hope you've enjoyed yourselves. If you have, please give me a thumbs up, and I will see you next time.